بسم الله الحمد لله والصلاة والسلام على رسول الله. الطلبة الأعزاء، السلام عليكم ورحمة الله وبركاته، وأهلا ومرحبا بكم في هذا الجزء السادس من المحور السادس لمادة نظرية الآلات Theory of Machines، والذي بعنوان Gears. Here I will present some features of simple gear trains. When there is only one gear on each shaft, it is known as simple gear train. You can see here, on each shaft we have one gear, okay, one gear on each shaft. This is called a simple gear train. So since the gear 1 here, for example, drives the gear 2, therefore gear 1 is called driver. The input here is called driver, and the gear 2 is called driven. This is the output or follower. It may be noted that the motion of the driven gear is opposite to the motion of a driven gear. We can see here the direction of rotation for gear 1. It is opposite the direction of rotation for gear 2. For the calculation of gears, so the most important thing is to calculate or to find out the speed ratio. Okay, so the speed ratio for simple gear train is equal to the speed of the driver divided by the speed of the driven. It is also equal to the number of teeth on the driven divided by the number of teeth on the driver. And also we find here the train value, it is the opposite of the speed ratio. So it is speed of the driven divided by the speed of the driver and equal to number of teeth on the driver divided by the number of teeth on the driven. Let's move now to compound gear trains. So when there are more than one gear on a shaft, then the gear train is called compound train of gears. We can see here for this shaft, we can find two gears. Here also for one shaft we have two gears. This is called compound gear trains. Some advantages to the compound gear trains. So much larger speed reduction from the first shaft to the last shaft can be obtained with small gears. If a sample gear train is used to give a large speed reduction, so the last gear has to be very large in case of simple gear train. Okay. Usually for a speed reduction in excess of 7 to 1, a simple train is not used and a compound train or worm gearing is employed. Here we have on this figure compound gear train. So the speed ratio, it is equal to speed of the first driver, first one, divided by the speed of the last driven or follower. This is the driven, okay? It is also equal to the product of the number of teeth on the drivens divided by the product of the number of teeth on the drivers. Train value is the opposite of the speed ratio. So let's see here the speed ratio, it is equal to, let's see here for this example, product of the number of teeth on the driven. So the driven here, driven gears are number 6, number 4, and number 2. Then here we find Z2, Z4, Z6 divided by the product of the number of teeth on the drivers. So drivers are number 5, number 3, and number 1. Z1 multiply Z3 multiply Z5. This is the speed ratio.